Hello everybody, this is the next video in a series of videos on Python programming for engineers. My name is Mark Bakker and I work at the Delft University of Technology. Today we'll learn how to use the Ipython prompt in combination with the editor from within Canopy. After you start up Canopy, you get a welcome screen that looks something like this. To start the editor, we click on the editor button. And depending on your settings, you get something that looks like this. To get the Python prompt to show up, we go to View, Python on the top menu, and there is our Ipython prompt. We can drag this line up to make it a little bit bigger. And let me increase the font size so you can see it easily. This is the Ipython prompt. Ipython stands for Interactive Python. It's a prompt specifically developed to do interactive Python programming. In fact, they implemented some additional functionality that's not part of the regular Python distribution. Those commands are called magic commands, and we'll learn a few today. But let's first start with the Ipython prompt. The Ipython prompt just looks like a code cell in the Ipython notebook. And we can type any Python command. For example, a is equal to 3. And now a is equal to 3. Or we can just type a and it will echo it to the screen for us. We can make a loop for I in range 5, colon, and notice the Ipython, interactive Python indents for us automatically. We can print I, comma, or maybe hello, comma, I. Now to execute this loop, we hit the enter button one more time and you see it executes the entire line. So one of the big differences between the Ipython prompt and the Ipython notebook is that every line you enter or every loop structure you enter, once you hit enter again, is executed automatically. While in the Ipython notebook, you could have a code block and edit the entire code block before you execute it. But there's a lot of convenient features. There are a lot of convenient features in the Ipython prompt. For example, to get the previous command back, you hit the up arrow, which I'm doing now. If I hit the up arrow, I get the previous command back. If I hit it one more time, it was whatever the command was before that. Go one more up, I get them all back the way I want them. I can also define a function, for example, def test, and it takes as input variable x. Then I say a is equal to x plus 3 and return a squared. Now we have the function test defined, so I can call test with the value 2. And what do I get back? It first does a is 2 plus 3, that is 5. It returns a squared, so it should return 25. That works just fine. If I want to edit this function I just created, I can either hit the up arrow twice, but if the thing I want to edit is a lot of commands ago, I can also enter the first couple of letters, for example DE of the command I gave, and then hit the up arrow. It right away finds the last command that started with DE and echoes it to the screen. I can edit this. For example, maybe I wanted not to return a squared but a cubed. And if I now call test with 2, I get 5 to the power 3, which is 125. I can also create graphs from here. For example, we take x is linspace from 0 to 4 times pi and 200 points, and y is the cosine of x squared, and I do plot x versus y, and there's my graph. Notice the nice feature we have here is that the graph shows up in a separate window, and in fact that window has a bunch of buttons at the top. Let me explain this one, for example. This one is the zoom button. So if you click that, I can zoom in on the graph. And then this second button right here is the pan button. I can pan around in the graph, try to find anywhere else I want to go. I can go back to the previous figure I saw, the previous layout I had, or if I hit the home button is just like the home button on a web browser. It goes to the very first time I created the graph, what it looked like. Then there's a couple of other things here, most notably this little disk thingy. I assume none of you guys know what a floppy drive is, but if you click on this, you can save the figure. A nice window pops up, you can give the figure a name, you can choose what format you want to save the figure in, and you're done. But you can also add more things to this graph. So if I type, for example, here x label x-axis, you see it nicely added the x-axis here, or I can plot something else, plot the sine of x versus the sine of x, and make it red. You can add that to the figure. You can make it as nice as you want. After you're done with the figure, you can either close it by hitting the X at the top, and on your Windows machine, I think that's somewhere on the upper right hand side, or you can do it from the prompt by just simply typing close, or close all if you have multiple windows open, multiple figure windows open. Next, we're going to write Python scripts with the editor and store them in Python files. First, we're going to create a new file by hitting the button here, create a new file, or do at the top do File, New, Python file. You notice it opens up here at the top. That's not a very convenient location. What I want is I would like to have them side by side. So if I drag this side, top of the Ipython prompt to the right until your screen looks like this, it nicely puts them next to each other. I can make the window a little bit wider, and now I can type on the left side my Python scripts, and on the right side I have my Ipython prompt. For example, let's create a function and let's call it func. It takes as input x and it returns the e to the power minus x divided by 8 times the cosine of x. I create x to go linspace from 0 to 8 times pi, and I take 100 points, and I calculate y as being the func I define of x. I'm going to store this file in a Python file, so I do file save as. It asks me where do I want to store that, and I want to store it in a directory I made for this called py files, and I give it a name test.py. I suggest you pick a better file name than that. I hit save, and now I want to run this file. To run this file, first I have to go with my working directory to the directory where this file is stored. The working directory is shown here. Right now it's at users mark. That's not where this file is. This file was stored in a directory called py files. To go to the working directory, you want to click on the little arrow next to this and choose change to editor directory. So now it's at the py files directory. So I'm now in the correct directory, and now I can type here run and then the name of this file, which is test.py. And I get an error message. Name linspace is not defined. Why is that? Well, the reason for that is when you run a Python script from a file, you have to tell that file which packages to import. In this case, we want to use functions from the pylab package. The pylab package, you might remember, contains all the array arithmetic and the mathematical functions that are part of the NumPy package, and all the graphic capabilities that are part of the matplotlib package. When we started the notebook in previous exercises, or when we are working from the Ipython prompt on this side, pylab is automatically loaded. But when you want to run a file, we have to import that package once at the top of the file, so we can use all the functionality in that package. To do that, we type from pylab import star. We save again, either by going to File and Save, or by hitting the shortcut for that. We go back here, we type run again, or I type RU and hit the up arrow. It finds the last time I used a command that started with the letters RU. That's the one I want. I hit enter and it runs. Now to see if it runs, I could make a graph here that it is correct, but I want to create a graph from inside here. So let's do that. Plot X versus Y. I hit save again, file, or I can hit the button here. Let's do that. File, save. I go back here, I run it. And still no graph shows up. Why is that? Well, there is a very good reason for that. If you run a script from a file and you have plotting statements in there, to see the plot, you have to give one more command, and it's called show. Show is a function, so you have to open the parenthesis, but there are no arguments, and you close it. If you run that, so now I save this file again, I do run test, there is the graph I want, and that looks a lot like e to the power minus x divided by 8 times the cosine of x. Why do I need to give the show command? That sounds inconvenient. Well, it might be slightly inconvenient, but the reason is fairly simple. Every time you do a plot, it has to redraw the entire figure. And for the figure we just created, there's not much to that. But in general, it might be a lot of work to draw the graph again, because it might have a lot of lines in there, or be very complicated plot. So what you have to do is you have to tell it when you want it to plot, and then you do that by saying show. Working with Python files in the editor is very convenient. You can include additional comments. This is my first function, and you're very much encouraged to do that, so that when you read, you or somebody else reads your code, knows what's going on. So we can say create a figure. But we can also add a second function, for example. Let's create a function that takes the square of another function. Let's call it square me. It takes as input the name of a function and x values. And what it returns is it returns the function f that you give it. It could be any name, evaluated at x, but then square. And then here we have our x still defined from 0 to 8 pi. We calculate y as the square me of the function we already had, evaluated at all those x values. So what does that do? It calculates the function value at all those x values and then takes the square, and that's what it returns. And let's plot that. And of course, once you have a plot, you can label the axes. This is the x-axis, and you can label the y-axis, and you can make it as fancy as you want now. Fancy label. We have to save it again. Don't forget to save it before you run it, because else it will look just like what it looked like before. You type run, and there's your graph. And in fact, now you can still edit this window from the interactive prompt. We can go back here, and we can also say maybe plot, what do we want? Plot the sine x versus the sine of x with a red line to add to that graph. And there's our sine of x function. That's all I got for you today. Hope to see you next time.